Hello and welcome everyone. I would like to welcome you to today's webinar on calculating the real economics and environmental savings from natural gas engines. It's a pleasure to have you here today. This is a webinar that's jointly hosted by the High Horsepower Summit and those of us here at Stabilis Energy. As your host, my name is Dean Perselli. Currently I'm the Senior Vice President of Business Development at Stabilis Energy, and it's really my pleasure to be moderating this webinar with you today. As a little bit of a background, I want to provide a little bit of an understanding about Stabilis Energy and why we're excited about the opportunity to sponsor and co-sponsor this webinar. Stabilis offers customers a complete range of fully integrated LNG fueling solutions, spanning from LNG production to delivery and logistics, field service and support, and finally cryogenic equipment. Our aim is to help customers combat the rising fuel costs and meet emission mandates while gaining a competitive advantage in a sustainable, safe, and reliable way. As a partner here, we're especially excited to be joined with on this webinar because we feel it's extremely valuable for our stakeholders to be part of an open conversation about current engine technologies, fuel savings calculations, and relative and relevant customer experiences that are using LNG in their fueling operations today. As an industry, it's very critical that we have a common understanding of how we're communicating these economic and these environmental savings from the use of natural gas engines, so that each stakeholder, his expectations and company performances can be properly and better aligned. For those of you who don't know, I would also like to take a moment to briefly introduce our partner on this webinar, GNA. GNA is the clean transportation and energy consulting firm that organizes the High Horsepower Summit that's held annually. This summit has grown to become North America's largest conference focused specifically on natural gas for off-road applications. I'm excited to lead today's conversation about the economic and environmental variables that are related to natural gas engine technology, as well as to help stabilize and provide some continuity to the key terminology that our industry uses throughout. We'll be looking at these issues from the perspectives of the OEMs, the original equipment manufacturers that provide us those engine solutions, as well as a customer who's here to better tell the story from their perspective as well. So joining us today is David Froberg. David's the project manager at Caterpillar's Gas Engine and Dual Fuel Business Unit, which is a part of Caterpillar's Large Power Systems division. We're also pleased that we'll hear from Ed Alcorta. Ed's the Senior Sales Application Engineer with GE in the Waukesha Gas Engine business, and it's part of GE's Distributed Power Group. Last but not least, we'll have joining us a customer view from Robert Parbs. Robert is the equipment manager with the Technical Services Support Group within Nabors, in Nabors Drilling Department in particular. So today, we're going to cover a variety of topics, including the principles of natural gas combustion, the environmental and economic differences between different engine types, such as lean burn and rich burn technologies. We're going to talk about the key terminology and the calculation methodologies that these variables in the engine technology bring to terms like diesel fuel displacement, methane slip, and how those all together affect net present value calculations. And we're also going to hear real-world case studies of natural gas engines in actual demonstration. So today's webcast is designed as a small preview of the programming portfolio that's offered during the 3-day summit sponsored and held by GNA, which will take place this year in Dallas, Texas from October 27th to 29th. The High Horsepower Summit is North America's largest and most comprehensive event that's focused on these economic and environmental benefits of natural gas engines. And it's very widespread. It covers a variety of market segments such as marine, mining, rail, drilling, pressure pumping, and power generation. As a few highlights, you can expect to see at this year's summit global case studies from early adopters of natural gas technology across all of the named sectors, technical workshops that will provide a hands-on guide to natural gas project deployment, as well as the largest expo hall floor of natural gas equipment, including all of the leading engines, equipment, technology, and fueling solutions that we'll be covering and discussing today. There will be a variety of sessions focused on natural gas use throughout all of the high horsepower sectors. Again, this includes dedicated tracks for marine, rail, mining, the oil and gas industry, and power generation. Before we set sail, here are just a few things to keep in mind as we go through the following presentations. I encourage you, as listeners, to submit any questions that you might have for our speakers by using the Q&A box that's located in the lower right-hand corner of your screen. We'll be answering as many questions as possible during the question and answer period that will follow the presentations. You can submit questions at any time, and we'll add them to the queue as they come in. A full recording of today's webinar will be available for download on the HHP Summit website. Stay tuned for an email link to this recording within a few days following the end of this webinar session. At the end of the webinar, we kindly ask that you would take the time to complete our quick 30-second survey. For your feedback in terms of future webinars and opportunities like this will be greatly appreciated and will add value to our opportunities going forward. Lastly, for any technical issues and assistance during the webinar, please contact Grace Jamison at the website that's shown on the screen or dial her number. That's in the lower right-hand corner of the screen today. So please contact her if there's any technical difficulties on your end. With that, we're excited to get started. I'd like to introduce you more fully to our first presenter today. Dave Roberge is Product Manager at Caterpillar's Gas Engine and Dual Business Unit, which is again a part of Caterpillar's Large Power Systems division. This division is the group that's primarily responsible for product design and the manufacturing of engines that are being placed in all of the high horsepower market segments available today, inclusive of marine, rail, electric, power, and mining. Dave has been with Caterpillar for 27 years, and he's cultivated a distinguished career in marine applications, core components, engine performance, and quality. So Dave, thank you for being with us. We'll turn this over to you for your presentation.
Thanks, Dean. As Dean stated, I'm David Roberge, and I'm the Product Manager for Gas Development here at Caterpillar. Today, I'm going to talk to you a little bit about some of the exciting products and development and customer value that the Caterpillar natural gas engines can deliver. I do want to state there is more knowledgeable people than me, and they will be at the High Horsepower Summit in Dallas on October 27th through the 29th. And so I recommend, if you've not already registered, that you go ahead and do that and attend the HHP Summit and hear and see from them on more details of some of the things I'm going to highlight today. Oops. As Caterpillar, we're a leader in natural gas engines. Our main focus in the past has been in the electric power and gas compression markets, and we've been leading in that area for many years. However, with the abundance of natural gas at very low cost, we see this as a great opportunity to continue to increase our product capabilities in these two markets, plus invest and expand throughout the complete value chain from the supply side to the demand side of natural gas. On the supply side, we already have products in the drilling, pressure pumping or fracturing, production, and gas compression markets. So we've already got products there. A big area of the growth is in the demand for natural gas. As I stated earlier, we've got the electric power products out there, and what we're currently in production with is marine, and we're in the final stages of validation on mining and rail. We're going to continue to invest in these areas to increase our product range as well as capabilities to deliver even more value to our customers. When I talk about customer value, These are the 6 critical items that we feel customers are using to make their buying decisions. As we look at those critical requirements, the 2 that I consider kind of the base is to be the reliability and durability. Customers buy these products to do a job, and if they aren't delivering the reliability and uptime and long life, they will not see the potential savings they have from the low-cost natural gas. The other thing is it needs to have similar performance as a diesel engine. By that I mean that they need to have the transient capability and power density as a diesel engine. With these 2 items kind of the base, that leads you into being able to harvest and get the great fuel savings from the low-cost natural gas, as well as the potential for lower emissions. When I talk about the low-cost fuel, some people are, and the question in some people's minds are the significant drop in oil prices has reduced the gap between diesel and LNG. This next slide is a graph showing the over time the spread between U.S. diesel prices in blue to LNG in orange. The LNG is a diesel gas equivalent, and this is based on a U.S. average from the U.S. Energy Information Agency. And as you can see in the history, diesel and gas price spread has been about 2x, and in the recent history, it's significantly less. However, if you look at the data projecting out, we still see that spread coming and expanding back up over the longer term. So based on that, Caterpillar is going to continue to invest into these natural gas products, because we see the customer value of this low-cost fuel to allow them to get more value from their products. So even though the short-term and medium-term economics maybe are less right now, we'll see them returning, and the customer and will continue investing. The other critical customer requirement that are making people look at gas compared to natural gas compared to diesel is the emissions. If you look at the potential for natural gas engines, they have the potential to have lower soot, up to about 70% lower soot, 25% lower CO2, and potentially 25% lower greenhouse gases. At Caterpillar, what we're typically doing is setting our NOx emissions to whatever the current regulations are, and then maximizing the lower soot, the CO2, and greenhouse gas. So another strong buying criteria and a benefit is the lower emissions, and we see the potential of the natural gas engines to be able to deliver that, and in some applications, depending on the system architecture of the gas system, even can eliminate aftertreatment. Again, I've talked a little bit about some of the products. As I go into more detail, you'll hear Caterpillar talk about dynamic gas blending, or DGB. Dynamic gas blending is really our term for dual fuel engines. We're using this technology to deliver up to 70% diesel displacement in typical diesel applications like drilling, pressure pumping or fracturing, and marine engines. As stated earlier, we also have locomotive engines and mining products in the final stages of validation, and are close to releasing those to production. Many of these products are also available for field retrofit, and one of the advantages with a Caterpillar integrated solution is that as we're developing these engines, we're maintaining the original emission certification, and on some applications like in oil and gas, we've actually been able to reduce the emissions and improve from EPA Tier 1 to EPA Tier 2 type of levels in our field retrofits. Some of these products, like the MAK, the M46 dual fuel marine engine, which is also in production, is able to meet future emission regulations like IMO 3. And then we have the EMD Lowcost 710 in production, on field trials, and again, it can meet current emission regulations for those type of applications. Here's another example of a DGB product that's under development. This is and delivering customer value. This is a graph over time. So the x-axis is time, the y-axis is gallons per hour of fuel, and you can see the red line is the standard diesel truck. So that is when DGB would be turned off and the engine's running 100% on diesel, and you can see the fuel usage. As the truck is the DGB system or the natural gas is turned on, you can see a significant drop in the diesel usage. This would be the diesel displacement. Based on our tests and evaluation, we're getting up to 60% diesel displacement in a typical mine cycle with our technology. Again, this product can deliver that diesel displacement and still meet the similar transient and power levels of the diesel engine. In our test, operators have commented that they cannot tell any difference between the mine truck running in diesel mode versus the DGB mode. The other key thing about this product is that it still has 100% diesel backup. So if the customer needs to switch back to diesel, it's easy to switch back and run on diesel if the fuel prices demand it. As I mentioned at the beginning, initially Caterpillar experiences it mainly in the electric power and gas compression markets. Electric power is typically in the 100% gas spark-ignited technology. We continue to invest in this product also. We've just recently released the 10 megawatt engine, the GCM 34, and we also have products in the turbines up to 22 megawatt. These engines can run on a wide range of fuels, from propane, commercial grade pipeline gas, to digester and landfill gas. But the key thing that these products typically demand is high electrical efficiency and high reliability. Caterpillar is continuing to invest in these products. We recently launched the 3500, the G3500H engine, which has market-leading efficiency in the 1.5 to 2.5 megawatt power range of over 45%, and it can also deliver very low emissions, has market-leading low maintenance costs and an 80,000 overhaul life. We're going to continue investing in these products as we continue to improve the efficiency and deliver the best customer value. As I mentioned, gas compression is another key market for Caterpillar. We continue to invest in this market also. We offer a complete range of engines and turbines that can operate on a wide range of field gas. We recently announced the 3600 A4 engine, which is upgraded from the current G3600 engine family. This new product has a 5% increase in power and can operate on a wider range of field gas and up to higher altitudes. The engine is doing this while going to lower emissions. The engine has the capability to go down to 0.3 grams of NOx for emissions. As I made statement, we're continuing to invest in this, and we're leveraging the technology we applied to the 3600 to other engines in the product line to continue to lower the emission levels of our engines and increase the fuel flexibility of those engines to operate on field gas. So in summary, I've given you a brief insight to some of the Caterpillar natural gas engines and their capabilities. We continue to see a move to natural gas because of the abundance brought on by the current drilling technology of the horizontal drilling technology there, and the shale gas deposits in the U.S. and around the world, which are shown in the upper picture in red. Due to this, we've got the low cost and abundance, and that can drive significant customer value with lower owning and operating costs. But it will be influenced by emission regulations, and we continue to invest in lowering our improving our emission capability of our gas engines. As I stated, we've got many spark-ignited dual fuel engines in production already in all the targeted markets. We're continuing to invest in them and improve their capabilities, and also increase the product scope and range of the products we've got in those markets. Again, I recommend you sign up, and please come to the High Horsepower Summit in Dallas in late October, and you can learn more about our products and capabilities and hear from our experts there, and also from my VP, Tana Utley, will be there that you can meet her too. Any questions on, oops. We'll turn it back over to you, Dean.
Thanks, David, I appreciate it. I hope our listeners keyed into some of the things, the keywords that I heard here, which was invest, invest, invest. To our listening audience, I want to remind you that sometimes the complexities of the time frame and the details that it takes to put these products out on the line, many of the things that David mentioned here, sometimes the timing and the requirements to get those solutions perfected to the market, those are silent times. We don't often hear about that during development, but it's very exciting at this particular moment in the LNG industry to hear that Caterpillar is on the verge of presenting our market a series of new solutions. And we'll look forward to the questions specifically, David, on topic with each one of those markets. So thank you very much for the update. Before our second presenter, I want to quickly remind everyone that's listening to continue submitting your questions on the Q&A session by using the box in the bottom right-hand corner of your screen. So at this point in time, we'll hear from our next speaker, Ed Alcorta, who will be replacing Corey Honnell, who was originally scheduled to present, but due to a last-minute switch, Ed is here, and we're happy to have him here providing this update on GE Waukesha. Now, Ed is a Senior Sales Application Engineer at GE Energy Gas Engines. And Ed, with that, we'll turn this presentation over to you as we're excited to hear what Waukesha and GE has to say on topic here.
Okay. Thank you, Dean. Yeah, this is Ed Alcorta. I plan to speak here a little bit about gas engine terminology and some of the questions we typically get from maybe people that have been traditionally using diesel engines that are new to the natural gas engine industry. So with that, I'll speak a little bit about rich burn and lean burn. What does that mean? What are some of the differences in natural gas spark-ignited engines? And then a little bit about fuels. So in the industry, you may have heard about Methane Number. Waukesha happens to use a different indice that I'll speak about here as well, and try to explain some of the differences there, as well as answer any questions that may come up. So with that, I'll sort of dive into the rich burn and lean burn differences. Waukesha is a manufacturer that does produce both types of technologies. So when we talk about a rich burn engine, what does that mean? To us, that means an engine that's operating at stoichiometric air-fuel ratio conditions. And what that means is stoichiometric air-fuel mixture is one that's theoretically ideal in terms of the exact composition of the exact ratio of air and fuel to burn 100% of each in the combustion chamber. So in the industry, we tend to call it rich burn, but technically it's really stoichiometric ideal combustion. And then we have lean burn engines, and a lean burn engine is one that on purpose is using more air than you theoretically need to burn in the combustion chamber. So I'll speak about that a little bit here as well. So one topic that comes up quite very frequently and is becoming more and more important is emissions. So what happens with one of those emissions, NOx, with rich burn and lean burn engines? Well, you can see here on the left, when we're operating at an engine at stoichiometric conditions, or a rich burn, at a lambda ratio of approximately 1, that's operating at really the hottest possible exhaust temperature in the combustion chamber, so the components have to be properly designed for that. And when we talk about a lean burn combustion engine, that means usually it's a lambda of 1.5 or higher, which means it has at least 50% extra air than it needs to for theoretical combustion. And what happens with NOx at those different ratios, at a more stoichiometric ratio, right out of the engine, the NOx is quite high compared to a more lean burn engine. As the mixture gets leaner and leaner, the combustion temperatures decrease, and when you decrease the combustion temperatures, the NOx also decreases that comes out of the engine. Okay, so this slide actually has quite a bit going on, but I'll try to summarize it here. So again, at the bottom is the lambda that shows approximately where a rich burn engine runs in terms of air-fuel ratio, and then where the lean burn engines tend to run. What this is trying to show is there's no one case where a rich burn or a lean burn is always better than the other. It depends on the application. So one advantage of rich burn engines is because it's operating at that point where the air-fuel ratio is ideal, it's a little bit more forgiving if that happens to change a little bit, if the load is decreasing pretty drastically on the engine, or if the speed's changing quickly. The engine can react very well because if it varies a little bit from that stoichiometric, it can recover quite quickly, and that combustion is already very robust. So one of the advantages a lean burn has, on the other hand, is it can operate at a higher efficiencies and higher loads for a given engine size because you can actually increase the pressures and temperatures inside the cylinder more before you get into what we call a detonation, which is a region we always want to avoid. That's what we call NOC, also, if you've heard the term NOC. So a lean burn engine can operate at higher loads without getting into that zone because of the cooler combustion that's happening. Okay, but at the same time, it has a little bit narrower window of operation where you have to be a little bit more careful if you have some parameters changing very quickly. There's a little bit more risk of getting into either the detonation region or the lean misfire region if you don't have the proper controls on those types of engines. So then back to the topic of emissions with a rich burn and a lean burn engine. Natural gas engines in general do very well with emissions, but they do that a little bit differently. So as I mentioned, the lean burn engines, they can get to very low emissions levels without having any after treatment on those engines. And mostly I'm referring to NOx in this example. A rich burn engine, on the other hand, I mentioned that the level right out of the engine is quite high for NOx because of the combustion temperatures are fairly high. However, with a rich burn engine, it's pretty easy to reduce those emissions very drastically and get really the lowest emissions possible in the industry when you apply what we call a three-way catalyst to the exhaust of a rich burn engine. And a three-way catalyst is very, very similar to what you see in the automotive industry, for example, on a gasoline engine. So what happens with a lean burn engine, if the engine out emissions in terms of NOx is not low enough, maybe in some specific regions in the US or elsewhere, they can still be lowered, but they require an SCR to lower NOx emissions further. So that's technology that is proven, it's available. It's just a little bit more complex and requires a continuous supply of urea or ammonia injection. And there's just fundamental differences between rich burn and lean burn to use a different technology. So the lean burn engine, it's running at lower temperatures, and there's an abundance of oxygen in the exhaust, so it needs a different kind of after treatment to treat it. It's the reason why it can't use a three-way catalyst on the lean burn engine. And this table summarizes some of the differences between rich burn and lean burn, some of the advantages of each in very general terms. So in terms of emissions, when the rich burn is paired with a three-way catalyst, you can get extremely low emissions. A lean burn with just the engine, without any after treatment, can get very low emissions levels still. When I talk about load acceptance, that means most of the time people think of this a little bit more for power generation, but in an application where the load is changing very frequently, you have high transients, which diesels are quite good at attaining. The rich burn can get very comparable performance to diesel, whereas the lean burn, the load steps, the amount of load it can take in one instantaneous step tends to be significantly lower than a comparable rich burn engine. The fuel consumption is better on a lean burn, so on a rich burn engine that is one of the trade-offs. All other things being equal, the fuel consumption tends to be somewhat higher on the rich burn engines. The fuels, this can vary a little bit depending on specific models, but generally the rich burn engines have a high degree of fuel flexibility, where if we remember that the chart that had the window of operation, if the fuel changes a little bit, it does not have a drastic effect on the performance of the engine because it's operating at the very robust window at the stoichiometric condition there. However, an advantage of the lean burn engines with the fuels is in applications where maybe you have a biogas fuel, and those fuels can sometimes have contaminants. With a rich burn engine, if the fuel has certain contaminants, for example, high amounts of H2S or siloxanes or other contaminants, then that can cause issues with the three-way catalyst. So that's one thing to be aware of. And then in applications, this can vary, of course, based on specific models, but traditionally we have applied the rich burn engines in very remote locations that tend to be running on field gas. In other words, gas that's coming out of directly out of the ground, wellhead in environments. So that leads us to the next topic I wanted to discuss here, and that's the Waukesha NOC Index. So what we have in the industry is when we talk about diesel fuels and gasoline fuels, the NOC Index is the cetane number or the octane number. When we now switch and talk about natural gas engines, we measure that NOC Index in a different way. And typically in the industry, the term methane number has been used as an index to measure that NOC resistance. Waukesha has another index that I'll explain some of the differences here shortly. And then we call that Waukesha NOC Index, or WKI. And in general, what happens with natural gas and field gases is you start with methane. Both the methane index and the Waukesha NOC Index are methane-based. That means 100% methane is 100 on these scales. And as you get to the heavier hydrocarbons, ethane, propane, butane, the NOC Index goes down, and the heating value increases. So they tend to be inversely proportional, NOC Index and heating value. So what exactly is the Waukesha NOC Index? This was developed in the 90s, and what Waukesha noticed, well over 20 years ago, we had been using motor octane number and then different methane number indices. And what we noticed, because most of the Waukesha engines, especially at that time, were operating on field gases or wellhead gases. Those gases tend to have a large amount of the heavier hydrocarbons. And we started learning that we didn't feel that the current methane number indices that the industry tended to use took some of those heavier hydrocarbons into account very well when it was doing the calculation. So Waukesha partnered with Southwest Research Institute at the time, and using an engine that was one of Waukesha's own engine for rating fuels, actually, did some experimentation and developed what we call today the Waukesha NOC Index, or the WKI. So that's where it started from. And here we have a plot of MN, or methane number, versus WKI, and this was just taking a sample of, or a large variety of different samples for field gases that we tended to see. And we plotted those on a scale. Here you have heating value on the lower axis, then you have the NOC rating on the left. And what we tended to see was, number one, for the most part, the Waukesha NOC Index tended to rate the fuels higher, and we felt that was more realistic. And then the second was that you see less scatter here with the Waukesha NOC Index. So we feel that's a better representation of what the real NOC Index of the fuel will be in practice in the engines when they're running in the field. And even though you hear the term methane number out there, there's sort of industry standard ones, and different manufacturers also have their own versions. So actually there's not just one version of methane number, there are quite a few out there in the industry. Here's some typical ranges of the NOC Index versus lower heating value. This is just representative. What we like to tell people is there's no one-to-one correlation with any other thing. It always really depends on the actual fuel composition to do an exact calculation, but this does give a rough idea of how heating value tends to correlate with the NOC Index. And now this slide has a few different real-world examples of the fuel composition with all the different constituents that you can find in wellhead gases that come out of the ground. And you see here what the lower heating value is for those fuels, and then what the Waukesha NOC Index is representing for those fuels. So you see the first two samples have a pretty similar NOC Index, but on the other hand, the composition of those gases is quite different. One is much higher methane content. The second one has much lower methane content, but it has a high inert, so it has a lot of CO2 in that fuel. And at the same time, it has quite a bit of the heavier hydrocarbons. So there isn't always an exact correlation between NOC Index and heating value. But we feel we're fairly confident with the Waukesha NOC Index that we're properly capturing the real NOC Index of those fuels, which allows us to rate the engines more precisely when we go to apply power ratings to our engines for specific sites. So that's the last slide. That's the last slide I had. Free to pass it over to you, Dean, and I'm happy to take more questions later.
Thank you, Ed. I appreciate it very much. I think our listening audience is beginning to understand that while you as OEM manufacturers are striving to cover a wide range of fuel source supply opportunities, which is good for the customer needs to understand that there needs to be some very specific feedback to you so that we can actually, or that you as the engine manufacturer can control output performance. There's a definite crossover and related relationship between emissions and power efficiency, and I think sometimes we as end users sort of think that engines are created to do all things for us at all times, and I think we're getting an understanding here that by working collaboratively with you, we much more strengthen our opportunities to come up with the right solution for a particular application. So thank you very much for that, Ed. Well, for our final presentation, we're going to hear the perspective of the view of natural gas engines from a customer. We're pleased to have Bob Parbs with us today. Bob is the equipment manager with the Technical Support Services Group within Neighbors Corporate Services. Bob has a high level of expertise involving maintenance systems, the electrical equipment, the mechanical equipment, and the overall project management that's necessary to incorporate these new natural gas opportunities. He's currently the leading authority regarding biofuel options for diesel engines within Nabors, and we're pleased to have him here today sharing his view and experiences with us. So again, for you as a listening audience, as Bob is sharing his progress and his learnings, let's make sure that you're continuing to submit questions for our guest speakers by using the Q&A box in the lower right-hand corner of your screen. So with that, Bob, I'll turn it over to you, and we're looking forward to your presentation.
All right, thank you, Dean. All right, I titled this LNG in the drilling industry, but it could be, you know, natural gas in general. It comes from several different forms, you know, wellhead, field gas, CNG, and LNG. The benefits, which we've heard everyone else talk about, you know, economics. First off, it saves fuel cost. Even though as a driller we typically don't purchase the fuel ourselves, the operators do, but our equipment has the biofuel capability, so that's an incentive for them to use our equipment so they can save the fuel cost. So it's a win-win economic situation on that. Environmental, which we've talked about, when you burn gas, it just burns cleaner than pure diesel. And then, you know, efficient use of resources. In other words, we've got a lot of gas out there. We need to use it. You know, if you have a dual fuel capability, a tank of diesel will last you a lot longer than without it. Okay. I put together a little slide that shows some of the cost savings. I made some assumptions. There's a lot of variations on all this. Drilling rigs, every well is a little different, so we came up with an average, or 1,500 horsepower drilling rig, average fuel consumption is 2,000 gallons a day. Some days it's higher, some days it's lower. It depends what you're doing, but that's probably a fair number. All right, made an assumption, you know, diesel about $2 a gallon. I know it varies from the geographic region. And we talk about the gas substitution rate. All right, the substitution rate for when we're substituting the gas for the diesel ranges from about 15% at the low end to 70% at the high end. So the loads vary, and the substitution rate varies with the loads of the engine. It's limited. It will not substitute below, I think, about a 15–20% load, and it won't substitute much above about a 70% load, because you get into areas with methane slip and things like that, and pre-detonation, which you don't want. So again, we're using 40% as an average substitution rate. That's pretty close real world. You might actually get a little bit better than that. So the savings is going to be 800 gallons. So we're saving, you know, based on this example, $1,600 worth of fuel, but of course you've got to buy some fuel to replace that diesel you didn't burn. LNG is a little less energy dense than diesel is, so it takes, I rounded off to 1.7, it's actually 1.68 gallons of LNG equals 1 gallon of diesel. So if we're paying $1 a gallon for the LNG, that's our cost, $13.60. So we're saving $240 a day based on this example I'm using here. As the price of diesel goes up, I mean, historically right now, I think these are the lowest rates we've seen in a long, long time. So I think over time these things will trend up, and as the gap between the diesel and the LNG increases, the savings go up drastically. So in this example, we're saving a little over $87,000 a year in fuel costs. If the diesel cost is to go up to $3 and the LNG to $1.25, it jumps to $225,000 a year savings. If it would go to $4 a gallon for diesel, and even if it was $1.50 for LNG, now you've got savings over $400,000 a year. So minor changes can make big changes in the overall fuel savings. Okay, currently, you know, our support for, you know, natural gas we primarily use diesel engines for generators. And we have 60-plus rigs equipped with the biofuel capability. You know, we've got one rig operating currently with the 100% LNG. We had a little bit more. We had 2 engines running previously. And all our future rigs will have the biofuel capability. You know, we use quite a bit of the Caterpillar DGB stuff because I like the idea of putting Caterpillar products on Caterpillar equipment. So that's worked out really well. All right, some of the challenges we face is that the rigs aren't always located right next to a big interstate or a major metropolitan city. You know, the rigs are located where the hydrocarbons are, and it's usually out quite often in the middle of nowhere. LNG, again, they're centers, they're going to, or any natural gas distribution, they're going to try and locate those around the places where they can sell the most of it. So that some of the challenges are trying to understand, you know, where the rigs are operating and where all the distribution centers are to try and, you know, marry that together the best we can. And then, you know, the other challenge is just partly what this conference is doing right now, and that's educating everybody as to the benefits and the values of using, you know, LNG and natural gas. You know, the more we learn, the better the technology gets, the more incentive there is to want to use the natural gas. All right. In the future, you know, what we need to do is, you know, partner with the natural gas suppliers and the drillers and the end users. In other words, we have rigs located in various geographic locations. We have LNG suppliers that are adding to infrastructure. And we just need to understand, you know, where those infrastructures are, how they overlap, and how we can work together to, you know, give the best value to all our customers. That was, you know, pretty much just a pretty quick overview of what we have, and that's my final slide. I'll turn it back over to you, Dean.
Thanks, Bob. I appreciate it. On behalf of our listeners, I think they would echo what I'm about to say, that when you have a real-life customer like Neighbors, as you said here, your future viewpoint and perspective on natural gas is to provide your customers with the opportunity to make that decision. And that's a big investment decision on behalf of Neighbors, and we're pleased and happy to see you making it. And we also agree, your last slide, where the integrated effort or the collaborative effort between LNG suppliers, you as a driller and a service provider, and end customers, it's paramount. And we'll look forward to talking more, particularly at the conference, and maybe some questions here about how we can help enhance and further that collaboration effort. So thank you so much for your time there, Bob, and for your material.
Right.
So listeners, right now at this time, we're going to, transition to the moderated question and answer portion of the webinar. I want to extend thanks to all of our attendees, and also want to thank you as listeners for submitting some incredibly complicated, in some cases, and some very insightful questions along the way. So for our first question, I want to address this one specifically to Dave at Caterpillar. Dave, you mentioned some new product lines coming out by Caterpillar, and you have different engine divisions. The question that we were posed is, can you explain if all three of Cat's marine brands, MAK, EMD, Cat, do all of those have gas or dual fuel products already in production, or do they plan to be in production under development for the marine industry in the near future?
So yes, when we talk about the three different brands, MAK, EMD, and Caterpillar, the MAK already has the M46 dual fuel engine in production. We've got units out running with very satisfied customers on that. We also have EMD is installing their first units on the dual fuel DGB units on the EMD 710 engines and some marine engines here in the U.S. And then the Caterpillar brand, we've got the 3500 marine engine is under development right now to have a DGB version of that.
Man, fantastic. Let me hit you with another question, Dave, while you're available here. We heard in your presentation a couple of times that CAT is fully invested in and continues to invest in this natural gas engine technology space. What can you tell us about the investment for the markets ahead? In other words, is there a priority of markets that you're looking at investing in, or do you have a plan for marine as well as mining as well as rail? What differentiates those markets for Caterpillar in terms of investment?
So the main driver there is where can we deliver the most value to our customers, and where can Caterpillar generate revenue for us. Right now, we're developing in all the target markets that are shown there: rail, marine, mining, the oil and gas with drilling and fracturing, and electric power.
Fantastic. I think obviously Caterpillar has a very large and internally very competent marketing staff, but for the listeners here who are listening on this webinar and who plan on attending the conference, we encourage you to take time, talk to all of our presenters, talk to all of the OEM companies, because Dave, I think you would agree that the customer's viewpoint, what the customer is needing, what technology, niches, and segments they're after, that has a huge impact on where and how quickly CAT invests its dollars, I would think.
Correct. Yes, we're interested in where we can deliver customer value. So any input we can get from our customers will really help us focus our technology development and the products we put in production.
Great. Thank you, Dave. I'm going to turn a question over to you, Ed. This is a very interesting concept about how GE Waukesha has addressed the Methane Number Index and what precipitated the development of this Waukesha NOC Index. When you look at rich burn engines versus lean burn engines, and you had a diagram there that showed the application window across a variety of sort of gas compositional supply sources, is there a typical or a certain engine horsepower size where rich burn or lean burn is found more beneficial one over the other?
Sure. So I'll try to answer that. Theoretically, there's not one cutoff or one limit of a horsepower size or engine size or anything like that where you have to switch over from one to the other. But that being said, in practice, we have seen sort of a cutoff, and that's more application dependent. So I guess what I mean is for the Waukesha size engines, the largest engine where we applied in a rich burn technology is 2250 horsepower. And as we get to the very large horsepower range, I mean above 2,000, up to 5,000 and even higher, we tend to see only lean burn engines and that very high horsepower. And the reason for that is the rich burn engines, you tend to find the smaller horsepower, the relative smaller horsepower closer to the wellhead, maybe where you're doing drilling, maybe where you're doing gas gathering applications, or in other words, more upstream, where the fuel cost is not as critical, but the fuel flexibility is very critical. On the other hand, when you get to the larger horsepower engines, they tend to be maybe in gas processing plants or gas pipeline compression, and at that point, there's more value in the gas. There's been more processing that's been put into it, so the fuel efficiency then tends to become more important than the fuel flexibility. So for that reason, theoretically, there doesn't need to be a split between rich burn, lean burn in terms of horsepower, but traditionally we've seen that split around those horsepower ranges due to more where the customers are putting the engines.
Great. Thank you, Ed. Hey, question on safety. It's interesting that from an OEM perspective, obviously you have safety at first and foremost at the front of your engine technologies, but as you work with customers, have you heard, what is their view on the benefits or the safety concerns at the engine level? I'm talking about mechanics and operators. Does there seem to be a safety concern with natural gas over diesel?
We've seen, I mean, I can say that in general, two things that there's been a lot more awareness of are emissions and safety, operator safety. So our engines today, and this probably is across the board for other OEMs as well, not just Waukesha, but we have, safety is a lot bigger focus than maybe it was 20, 30 years ago. The control systems on the engines are much better. They can react much quicker if there are any faults. So the control systems have been specifically designed. There's a lot more critical emergency shutdowns if the engine sees certain parameters going wrong. But inherently versus diesel, you know, just on the engine, we've not seen any major differences, I guess, in terms of safety between natural gas and diesel at the engine level itself.
So a lot of times this is really just about awareness and training and bringing up to speed people who are used to working with one fuel source and just orienting them properly toward another. That would be a great benefit to what you're seeing out in your customer set then as well, I guess.
Absolutely. Training is absolutely key. So while there aren't, I would say, in general, with a recip engine, major differences in terms of safety, the training has to be there to make sure that the engines are being operated the way they're supposed to be. And in terms of the way they're operated, there may be some differences here and there that the operators certainly need to be aware of and be conscious of.
Okay, great. Robert, quick question for you. It looks like Nabors is making a big investment in the future in dual fuel engines and perhaps dedicated engines as well. So this is sort of the loaded question here, but from a Nabors point of view, do you think natural gas and LNG is sustainable as a fuel source for the industry over the long haul?
Oh, I definitely do. I mean, there's several reasons for that. You know, right now there's a lot of restrictions on flaring, so all this gas that was previously being burned, the operators have to do something with it. You know, most of the wells that are drilled out there, although people think they're oil wells, there's probably more gas coming out of them than oil. So, you know, there's a lot of natural gas present, and then there's a lot of companies investing a lot of money in infrastructure for, you know, natural gas, LNG, you know, processing plants and what have you. So, you know, I think it's definitely a fuel of the future. And, you know, it's you know, a very usable form of fuel, and it doesn't require all the processing that the normal crude oil does.
Yeah, thank you, Bob. We agree with you. I'm going to throw out one question sort of to the general audience here, and perhaps we'll start with Dave and followed by Ed as the OEM manufacturers. There's this talk about methane slip, and from an OEM perspective, can you clarify for the listening audience what exactly is methane slip and how should we define it when we think about our conversations forward? David, we'll start with you.
Putting me on mute. Methane slip would be really a measure of the amount of methane in the exhaust, and methane slip can be, most people think it's the gas just going through the intake and back out through the exhaust, but it can be partially burnt or unburnt methane as it's going through the combustion. And different technologies of engines have different levels of methane slip or methane in the exhaust.
Thanks, David. So Ed, you know, from a Waukesha perspective or a Caterpillar perspective, just as an OEM, then this methane slip issue is something that we have to deal with as an industry, and it's important for people to know that this does, in fact, affect their economics. So when it comes down to diesel displacement, that's, I guess we would say, and I'm looking for your clarification here, diesel displacement would be that part of the diesel fuel load that's effectively and efficiently being substituted and take the space taken up by the efficient use of natural gas. And perhaps methane slip from an economics point of view would be that portion that is just inherently due to inefficiencies or improper fuel compositions going through the engine. Is that the right way to look at this, Ed?
I think it is. Can you hear me? I'm not sure if I'm still on mute here.
Yeah, we hear you loud and clear.
Thanks. I guess I'll address the two questions separately. I think for diesel displacement, I wouldn't have anything further to add. I think that definition is right on what I would have thought of it as in terms of displacing diesel with natural gas use. In terms of the methane slip question, I sort of see it on two parts. So one is on the economics. In my opinion, I don't see it greatly affecting the economics. So if we're putting natural gas with engine, whether it's LNG or CNG or a field gas, the methane slip is a very small percentage of that economically. So I don't think there would be a big loss of savings there. But the other way methane slip is important is in terms of emissions. So it's getting a lot of scrutiny from the EPA and from regulators. And one of the main reasons for that is that it acts as a greenhouse gas. And so as a greenhouse gas, we think of CO2 being the main constituent that affects greenhouse gases. But methane is actually 25 times more powerful than CO2. And so it's starting to get a lot of attention, whether it's coming out of the exhaust of an engine or whether it's coming out of a gas leak somewhere in the process as fugitive emissions. So it's getting a lot of attention that way. And there's some differences in technology in how much methane slip there is present in the engine. So I didn't talk about that during my presentation, but the rich burn engines actually tend to do very well and have very, very little methane slip because the combustion is very complete, okay, whether that's LNG or a field gas. The lean burn engines, in general, the leaner you try to make them, the little bit more fuel that escapes a little, that's not completely burnt. It's not completely combusted in the chamber because you're trying to make those mixtures very lean in the cylinder. So that's sort of how I view the methane slip.
Oh, thank you, Ed. So for you listeners, what it basically says is even though today methane, while it's not a recordable, if you will, contributor to greenhouse gases, there's a lot of talk in the industry about that becoming a regulated thing. So as we think about our economics forward, I think what we've heard here is we have to look at it from the economic side as well as the environmental impact side, and that makes us essentially socially acceptable operators here. So we're out of time here today, so I'm going to have to wrap up the webinar here. I apologize if we didn't get to a specific question that you as a listening audience may have submitted. If we didn't get to your question, be sure to register for the High Horsepower Summit itself. The drive and the opportunity here is that during these sessions, during these breakout sessions, we can continue to answer and you'll be able to continue to learn about natural gas and natural gas technologies with people like our panelists today. So we look forward to seeing you and hearing your questions at the summit itself. So I'd like to extend sincere appreciation and thanks to our presenters, Dave, Ed, and Bob, for devoting time to both this webinar and to the upcoming HHP Summit itself. So feel free for you as a listening audience to contact any of them or myself here for any follow-up questions that you may have. Our contact details will be included in the follow-up email that you'll receive tomorrow. We had more than 200 individuals register and participating today, and this draws incredible attention to the interest in natural gas, both as a fuel solution for our industry, as well as talking about some of the economic and the environmental impacts that are going to affect our high horsepower industry going forward. So we encourage you as listeners to continue your education. Join us at the HHP Summit, October 27th to 29th this year in Dallas. As you can see, HHP Summit webinar participants today are entitled to a $50 registration discount if you'll use the code when you register, webinar 50. So be sure and use webinar 50, and we look forward to your registration and upcoming questions at the summit itself. This year's High Horsepower Summit will focus on the need for inter-industry collaboration, which we heard about today, with early adopters of natural gas technologies making the case that tremendous synergies that exist across the marine, rail, mining, drilling, pressure pumping, and stationary power generation sectors. By collaborating, we're going to drive infrastructure development, we're going to drive technology and engine advancements, and the creation of up-to-date regulations and policies. All will stand together so that we will be able to benefit economically and environmentally from this shared initiative. HHP 2015 will include individual program tracks for each of the high horsepower industries that we mentioned today, and each industry track includes a full agenda with sessions that are tailored to meet the specific needs of the audience of each sector. So there's 3 days of tailored educational sessions, networking opportunities at hosted receptions, plus, as we said before, one of the largest expo halls available today for actually showcasing high horsepower industry engines, equipment, and fuel supplier technology approaches. So as a reminder, this recorded webinar will be available for replay via an email link that you will be receiving in the next couple of days. Also remember, please, to complete the brief survey that pops up once you exit the webinar window. We greatly appreciate your feedback in order to continue improving these HHP webinar series forward. So thank you for joining us today. It's our pleasure at Stabilis and G&A to host this webinar on your behalf, and we look forward to seeing you all in Dallas very soon. Thank you.